This music has got to be the best. It goes well with my dinner. I love that. That's a great emote. We're doing some C game development, starting with the easy stuff. That is what we are doing. So, get your stuff together. Head first, C projects. Chapter 2. I think we're still in chapter 2. It could be wrong. How did I modify Bermuda Sea? What did I do? So let's have a look, shall we? What is the PDF for this? That's right. PDF head first, test first, C. Oh my. That's right, we were on the mating game. But we moved on from that. We did all this stuff with pointers last time. We showed how this declares a pointer. This is the same as this. We did all that code. That's all there. We did this. We talked about the array. Well, let's read this. But array variables aren't quite pointers. Even though you can use an array variable as a pointer, there are still a few differences. For to see the difference, think about this piece of code. Char s blah char t equals s. Okay, so that and t and s are supposed to be the same. This is important. Let's read this. So size of an array is the size of an array. You've seen the size of a pointer returns a value of 4 or 8. Because of that, the size of pointers on 30-bit systems. But if you call size of on an array variable, C is smart enough to understand that you want to know how big the array is in memory. This is actually one of the reasons that I don't like using this notation. This is the S array. Size of is 15. 3, 4, 5, blah, 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 blah. This returns 15. Size of S. Return of 4 or 8. This is the T pointer. Size of 4 or 8 is 8 or say. So a size of S actually gives you the size of the array. I've got to try this right now. I got to try it right now. Incognito mode. Size of. I'm going to experiment with this right away. Size of. VI makefile. Size. We're going to say all. Size of. VI size of .c. Include stdio.h int main and return 0. And then we need, what do we need now? We need something fun to print. So if we say int, and if we have an int s equals something long, and then we have an int pointer t equals s. Yeah. Indoors. And why is it making me visual? I have prescription sunglasses that are nice, and I've been drinking, so my eyes hurt. Also, I was playing jazz earlier, so it likes it. I can totally see everything. It's crazy. All right, let's do this. So we've got yeah, there's like Christmas jazz on. I've been liking it. It's a little bit loud because it got. You know what? It's because I've been watching Cowboy Bebop. I just finished Cowboy Bebop, the whole series, which is completely lame. I'm gonna watch the actual anime now to make up for it. I feel dirty. Sweet glasses. They are actually sweet glasses. They are prescription. First pair of prescription sunglasses I've ever had. Also a little bit more consistent when it comes to, because they don't have bifocals in them like my other ones. He's doing Feliz Navidad. The live action. L, something along with L, you think? This is a widestring. How? What? I don't know what that is. Printf. Let's do printf. I size of array. S size of S size of pointer. And we're going to do T on this one. Would that be char T? No, we're not doing that. Very happy with them. Yeah, I and you know, I have lights and stuff. And it doesn't look like it, but I do. So make. Oh God. I keep forgetting. I'm going to have to use like, God, this is one of the things about Go I really come to appreciate. It's a long unsigned int. Both of them are long unsigned ints. So I'm going to do a long int. Actually, it's unsigned, so it's li will work, I guess. What? There you go. Can I initialize array of int? It's supposed to be char. Hello, idiot. Wait, why is this one not char? Oh, it is char. Ooh. Says one of them 16 and one of them 8. Why? We must understand this. So this, the size of S is 16 or whatever. With L string, that's why I was trying to tell you. It works though. What we need to understand though is that size of returns something different when it's pointing to an array. That is a big deal. That is a big deal. This does make me want to try this though. H. Yeah, I want to do string len. I. String len of S It's a pointer. It's it depends on where it is. Either declares it's going to be a pointer or long unsigned int li. All right, so that's 15. That is super interesting. All right, so the size, string length, array, string length, pointer. I want to see if it'll dereference the pointer automatically. This is very fascinating to me. There we go. So, the moral of the story, boys and girls, don't use size of. There's no need. Use string length. Then you won't have to deal with this difference. You get the same reliable thing every time. That is the takeaway from this. So, I mean, once again, let me show it. So the size of the array is 16 because it includes a null pointer at the end. The size of the pointer is 8 because it happens to be on a system of 64-bit, and therefore 8 bytes equals a pointer to memory. And then the array, string length array, takes care of all of that, chops the null off, and tells you exactly how long the string is for both cases. And it accepts either. I find this fascinating. This is something I didn't know. String length accepts either an array identifier, which is also under the hood a pointer, and it also accepts an explicit pointer. Hey, Van Fleet, pretty good. String length loops over the string to get the length. You're looping the second time. I'm going to put that there. Just don't loop using strlen since it loops itself to get length. How about that? I like that. All right, I feel like that's a success, a fun learning experiment. That's what this whole thing is telling us, that the address is different. The pointer variable is just a variable that stores a memory address, but what about the array variable? If you use the AND operator on the array variable, the result equals the array variable itself. If a coder writes and S, that means what is the address of the S array? The address of the S array is just S. But if someone writes at T, that means what is the address of the T variable? T is not equal to. An array variable can't point anywhere else. When you create a pointer variable, the machine will allocate 4 bytes by store. But what if you create an array? The computer will allocate space to store the array, but it won't allocate any memory to store the array variable. The compiler simply plugs in the address of the start of the array. But because the array variables don't have allocated storage, it means that you can't point them at anything else. Yet another reason not to use them. Pointer decay. Because array variables are slightly different from pointer variables, you need to be careful when you assign arrays to pointers. If you assign array to a pointer variable, then the pointer variable will only contain the address of the array. The pointer doesn't know anything about the size of the array, so a little information has been lost. That loss of information is called decay. So if you do it this way, the size of this memory or that's been allocated is preserved along with the S, and that's why you can do size of and get it. If you do it the other way, you don't get that, and you have to count it. That's cool. It's called the pointer decay. Interesting. Every time you pass an array to a function, you'll decay to a pointer, so it's unavoidable. But you need to keep track of where arrays decay in your code because it can cause very subtle bugs. That's why people hate C. In the case of the lethal list, the mansion had all the things that he dreamed of: landscape grounds, chandeliers in the bathroom, 94-year-old owner. Armory Mumford III had been found dead in a garden, apparently of a heart attack. Natural causes? The doc thought it was an overdose of heart medication. Something stank here, and it wasn't just a dead guy in the gazebo. Walking past the cops in the hall, he approached Mumford's newly widowed 27-year-old wife, Bubbles, of course. I don't understand. He always was so careful with his medication. Here's a list of the doses. Thanks for that, Lace. She showed him the code from the drug dispenser. Wow, that's great. Thank you for the follow. God, lots of fun follows. So here's the dispensers. Int doses blah equals blah blah blah. So here's all of his doses. The police say I reprogrammed the dispenser, but I'm no good with the technology. They say I wrote this code, but I don't even think it would compile. Will it? She slipped her manicure fingers into her purse and handed them a copy of the program the police found lying out by the millionaire's bed. Like that's going to happen. I certainly didn't look like it would compile. Printf issue dose %I 3 doses. This is interesting. What did the expression 3 doses mean? 3 wasn't an array. Well, let's see. Doses is a pointer. A good Linux distro, Pop! OS. That's my recommendation. Linux Mint or Pop! OS. There's a lot of others out there, but that's my recommendation. What did the expression 3 doses mean? It wasn't 3 in an array. Bubbles blew her nose. I could never write that. And anyway, a dose of 3 is not so bad, is it? Format specifiers? I have no idea. I think they're synonyms, but I do not know. Should we look? Ran printf. That's a good question. Let's go find out. Together. I love that you don't have to answer that question when you answer it with go. With arguments converted to proper first type, people will think that your system have its own version. Oh wait, that's not it. We need I think it's -5. Where's the C stuff, people? It's 5, right? Is it 2 or 5? It's man 3. There we go. Printf. I think there are some synonyms for integer. That's what I think. I tend to use I. Yeah, because F is the floating point one. So I'm almost positive they are the same. But let's read it. JKL. D or I, the same thing. God, look at this. The int argument is converted to a signed decimal notation. The precision, if any, gives it a minimum number of digits. The default precision is 1. When 0 is printed, that will precision of 0. Output is 0. There you go. They are the same. That's how you find out if you want to read about it. Mate or cinnamon? I'm a cinnamon fan myself. I like cinnamon. But, you know, everyone's got their own preference on that, so do what you want. I am definitely a cinnamon fan. Okay, what is this going to print? So 3 wasn't an array. Bubbles blew her nose. I could never write that. And anyway, a dose of 3 is not so bad, is it? A dose of size 3 wouldn't have killed the old guy, but maybe there was more to this code than me say. Oh, I think I know what's going to happen. I actually think I know what's going to happen here. So the 3 is an integer, right? And doses is a number. So what it's going to do is it's going to inflate the size of the array to be an 8-byte integer. And so it's going to be, it's going to make it fucking huge. No, it's not. Doses is not an array. Doses is the reference to the array. Yeah. So, yeah. This is going to be interesting. Why arrays really start at 0? Yeah, we should try it. Let's write doses. 8%. Right. So that's kind of what that's where I was going with it. So make directory doses. Yeah. 3 doses. Let's see. A to the n equals pointer to a plus n. When did they add that? Dereference. Well, we're doing pointers now, right now, Van Fleet. An array variable can be used as a pointer to the first element in an array. That means you can read the first element of the array either by using the bracket notation or using the pound up the asterisk operator like this, which I do all the time. I do both of these. But because an address is just a number, that means you can do pointer arithmetic and actually add values to the pointer value and find the next value. And find the next address. So you can either use brackets to read the element with index 2, or you could just add 2 to the address of the first element. Pointer arithmetic. So I equals drinks 2 equals drinks plus 2. So the pointer plus 2, whenever the memory address is plus 2, it equals that. This is the location of drinks. Yes. Drinks plus 2. Yes. This is drinks plus 1. This means you can put the base structure of a struct at the start and use the struct as the base struct. So C inheritance. Holy shit. In general, the two expressions, this and this, are the same. That's why arrays begin with 0. The index is just a number that's added to the pointer to find the location of the element. Sharpen your pencil. Using the power of pointer arithmetic to mend a broken heart, this function will skip the first 6 characters of the text message. All right, let's do it. Make directory skip. cd skip. va make file. All skip. vi skip .c include stud io.h int main return 0, and then make a function called skip void skip, and we're going to do a skip here, and we're going to skip a number, right? Oh, use the power of motor. This function will skip the first 6 characters of the text message. All right, let's put skip 6. Char pointer msg. Put s. we're going to be putting well, message is already a pointer, so we could do, god damn it. Why can't I see? Message plus 6. And down here, we're going to say skip 6. God damn it. And we're going to say message from Amy, don't call me. Character pointer. Message from me. Oh god. God damn it. To my sister say, don't call me. Skip message from me. How's it going, Kay? Uh-huh. 3+ doses. Right. Well, that's what I was going to say. It's a big number. I mean, it's a big fucking number because doses is an integer. So that's why it failed. Make what do I got there? What am I doing wrong? This is for me, from Moisers. Space after the star. I think you can have that's not a fatal error. Constant charges. What are you talking about? What you talking about? Oh, this one needs a space. Interesting. Has to be a constant. Return int constant char put us. Well, that's interesting. That's very interesting. Spaces are, normally the errors are not as spaces. They're not. That's just a style thing. I think it's how it's getting called, to tell you the truth. Which is no expecting or type char. Huh. I think this is because we're doing strict stuff. It's not going to let us do it. I don't think it's going to let us do it because I don't think it's going to let us do pointer arithmetic because we have warnings on. We have errors and stuff. I think it's not going to do that. I think it's going to give us shit, which is what it's doing. Because I mean, we're declaring a character array message. This is totally fine. Add constant keyword to function parameter. You think? Is there put us no? Because I mean, we'd have to cast it. Oh, I see what you're saying down here. Yeah, of course, that works. I find it fascinating that it has to be a constant. That's yeah. I don't know. Message char, but not. I see. It put s is the one that's giving us the shit. We can actually use stuff besides put s. Let's try that. Let's do put f, printf. Printf will do it better anyway. Right? Actually, no. That I see what they were trying to do. If you do that, it will truncate the beginning of the thing off and print it up to the null pointer. That's what put. That's why they were using put s. Yeah, I see why they're doing that now. So, assuming that's the way it's going to work. Put s needs a constant character. So I don't know. Makes a pointer from an integer without a cast. So yeah, this all the we turn all the warnings on, which is actually good, but I think we're gonna have to cast this. I think we have to cast this as a pointer. Yeah. Yeah, it says yeah, because we're doing, see here, we have inconversion errors on to keep us honest. Or add const to the front of the character in line 3. I don't know about that. I think we tried that, didn't we? Yeah. Expected constructs, but argument is of type char. So this down here is going to have to be const char as well. If that way is going to work. Argument is of type char. Yeah, there's a cast happening here. Well, the book has this doing something completely different. I mean, that is one of the options. Message plus 6. How does that compile? How does that... Was it not compiling because of the... I see what you're saying. Yeah, you're passing the pointer, so you don't need to... I think that was it. Yeah. Wow. That blew my mind. That blew my mind because this is setting... The message is setting the type and adding the number to it. It's just setting it... It's just changing it so it still fulfills the type. That's fucking weird. Because... Yeah. Oh, it was the pointer that was the problem. Okay. All right, so... Skip. Yeah, call me. That makes sense. That's fucking weird. That's why C gets so much bad thing. So this says, okay, this already gives us the pointer to the thing. So we just add 6 to the pointer. It's the same exact thing as saying message 6. See, that one won't work, right? That's interesting. No, because it's already a pointer. That would be a pointer of a pointer. Yeah, that's the thing. What if I did? I have to dereference it. Yeah. I mean, I don't know if that'll work. Let's try. Yep. Okay. Yeah, so we had to dereference it because it was already a pointer. Gotcha. This does the dereference. God, that's crazy complicated. Mm-hmm. Mm-hmm. When you're dealing with a pointer. Yeah. When dealing with a pointer. That's like really cool. That's cool. Add dash A. Yeah, let's finish reading. Always decay to pointers when you pass them. Yes, I think that's where they were. Yes. Yes. So this is just message plus 6. You could do that, or you could do the long-winded way too. Is love a place hard to get? Yes. Sharpen your slate. Because you get so much power, you're like dealing directly with memory, man. Like really directly with memory. I mean, to the point where it's like really scary, right? You're using the power of pointer arithmetic to mend a broken heart. Message +6. The function skips the first 6 characters of the text message. Message points here. So this is a pointer. So we just have to add to it. And we had to dereference it if we want to use the array notation, which we did in our test. Why pointer subtypes? If pointers are just addresses, why do pointers variable subtypes? Why can't you just throw all the pointers as some sort of general pointer variable? The reason is that pointer arithmetic is sneaky. That's the official reason. If you add 1 to a character to a sharp pointer, the pointer will point to the very next memory address. But that's just because the char occupies 1 byte of memory. What if you have an int pointer? Ints usually take 4 bytes of space. So if you add 1 to an int pointer, the compiled code will actually add 4 to the memory address. That's crazy. If you run this code, the 2 memory addresses will be more than 1 byte apart. So pointer types exist so that the compiler knows how much to adjust the pointer arithmetic. Wow. Okay, I think I finally get it. So if you take a pointer to a character array, to a numeric array, adding 1 to the pointer is going to do something completely different than adding 1 to an array of characters or otherwise a string. That is insane. So num is nums. So that's a pointer. Nums plus 1. Nums plus 1 equals. Remember these are address and hex. Yes. So that's like 4. 4-bit long has to be treated differently from 32-bit int. Absolutely. Yep. The case of Lethal List. Last time we left her here interviewing Bubbles Mumford, whose husband was out giving it over to the result of suspicion of the Bubbles. It's going to be some big ass number. Was Bubbles the coding culprit or just a patsy? To find out, read on. Bubbles actually killed the person by writing a code like that, for sure. He put the code in his pocket. It's been a pleasure, Mr. Mumford. I don't know what to Not so fast. Bubbles barely had time to grasp for her slapped her braces on her. I can't tell from your hacker manicure that you know more than you say about this crime. No one gets fingertip calluses like hers without logging plenty of time on the keyboard. Bubbles, you know a lot more about C than you let on. Take a look at this code again. So now that we know this, and we know that this is an int pointer, we know that int pointers are increased by 4 bytes every time. Then doses is going to be... Yeah, it is pretty weird. You knew you could use an array variable like doses as a pointer. The fatal 1000 dose could be written down like this. Doses 3 equals doses, which equals 3 plus doses, which equals 3 doses. Holy shit. That was not intuitive to me at all. I kind of like that. Takes a swig of brandy. It's completely ugly. It's just valid. This is a byproduct. This was not something that was intentionally designed by the language creators. It's just a byproduct of pointer arithmetic doing its thing. So doses, goddamn, this is cool. So doses 3 says, hey, doses is a pointer, right? So it says add 3 to the pointer. And since we're talking about integers that are and not a character array, and it's 4 each time, doses plus 3 equals 3 plus doses, which equals 3 doses. Your code was a dead giveaway, sister. It issued a dose of 1,000 to the old guy. And now you can never go corrupt C6 again. See, because you know why it did? Because doses plus 3. So doses 3 equals, it's 3 times doses. Yeah. That is fucking weird. That is fucking weird. So that means pointer, it is assembly. It is. It's just one layer on top of assembly. C is the closest to assembly you're ever going to get. Picking an array location. Yeah. This is why Go and languages like it are so important. Because they keep you from these esoteric kind of things. You can do other esoteric things, but not nearly as bad as this. 3 would actually work, yeah. If 3 was an identity. 3 would have to be a pointer to something. No, it actually wouldn't work. Because 3 can't be an identifier. I don't think you can use numeric identifiers. You couldn't have int 3 equals whatever. It wouldn't work. Yeah, right. Your code is always a dig away, sister. Bullet points. Array variables can be used as pointers. That we know. But array variables are not quite the same because they have knowledge of the fact that they are associated with an array. Size of it is different from array and pointer variables. You know, this is one of the reasons I like this book. I've never had a book explain this kind of shit to me, ever. And I've read like 2 or 3 C books. Size of it is different for an array and pointer variables. Array variables can't point. How's it for C going? It's going pretty good. Head First Go is old. The writing style is awesome, and they cover it very clearly, but it's just really fucking old. It's like, it was written in like 2014. But SHA 3 works. Holy shit. I don't know of a head for C++. I assume there is. I'm interested. I've got a renewed interest in C++ now that Flutter is getting picked up by Samsung. We can talk about that later, but there's already a couple devices that are using Flutter, Fuchsia, sorry. They're using Fuchsia as their OS, and they don't want to deal with Android. Not Flutter, Fuchsia, I'm sorry, Fuchsia. Samsung is a direct contributor to the Fuchsia project. And I read about that today. That's the first time I've given Fuchsia any serious consideration. Fuchsia is some like shitty project in Google, but all of a sudden Samsung's like, we want something that is not GPL v3, and you can't run Android because Android is GPL v3. I don't know. They want Fuchsia. Samsung wants Fuchsia, and another big company got on board. And Fuchsia, as you know, is a C++ operating system. Is written in C++. As operating systems go, those that have been written in C++ in the past have failed miserably. Haiku never really picked up. So it's going to be really interesting. You start the output books, yeah. So, like Windows. Well, strictly speaking, I don't think Windows is written in C++. All of it. I think the side stuff is written in C++, but the core is C, I'm pretty sure. I could be wrong on that. I don't know. Someone tell me what's up with that. But yeah, Windows is C. So there's never been a purely C++ OS. Yeah. Learn Go with tests kind of seems okay. I heard about that. on the Go Time podcast, and I thought I would give it a shot, and I wasn't impressed. But I'm not test-centric. I think that this overemphasis on test-driven development is misplaced. I think we need good tests, absolutely, but the tests should not be the way that people are obsessed with writing them. C++, Dart, Rust, Go, or Python, apparently. What are you talking about? I guess. Oh, we're talking about the Headforce books. Yeah. Right. Yeah. There's no Go. The Flutter project made. I'm sorry. The Fuchsia project went out of their way to banish Go from the project, but they allowed it to be written in Rust. So the reason I'm interested in the Fuchsia project is, number one, it's not just Google, and because Samsung's involved, and Samsung, they're not stupid at Samsung. Samsung knows what's up. As a smart company over there, and the fact that Samsung has invested heavily into Fuchsia and C++, and the fact that Fuchsia supports Rust and not Go, is the first time I'm going, let's see what happens here. If that actually gets legs, if Fuchsia actually gets legs as an Android replacement, over 60% of all mobile devices are running Android right now. And if that project gets legs, everybody will be writing C++ and Rust for mobile development. So I'm watching it very closely. I'm watching that particular project very closely. I still think Fuchsia's kind of a flash in the pan. I don't think it's going to be anything. But the fact that Samsung is giving it a nod really, really makes me take note. Because Google has a ton of pet projects that fail miserably. I mean, how many do I have to say? But when Samsung gets on board and they get another like really reputable software manufacturer in the mobile arena on board, then you're starting to like look at it. Yeah. 10,000 allows to see. Right. Bash. Switching core to Go attempt. Yeah, I don't know. It'll be interesting. Yep, it's gonna be really interesting. Anyway, back to our thing here. And I've said all along, as soon as somebody shows me something significant made in any of the other languages, C++, C++ has got a lot of significant stuff that's been made in it. I mean, the entire game development industry is C++ pretty much. I mean, the AAA one and all of the 3D studio space in Hollywood and everything. That's all C++. A few shoes is ELF. Yep. So, I mean, at the end of the day, it's just going to be an ELF compiled binary, which, if from terminal and writing apps from Java and a huge Android Studio IDE, I would too. I would absolutely love C++ over that. Stock trade data is written in C++. Absolutely. Yeah, C++ is really big for large, highly performant applications. And it has been for a long time, and it's going to stay that way because there's, it's not going anywhere. C++ is not. It has problems, and I don't particularly like how ugly it is compared to Java as well. I don't like those syntaxes, but it doesn't matter. It doesn't matter. Array variables can't point to anything else. Passing an array variable to a pointer decays it. In other words, it becomes just a regular pointer, which means if you did a size of on it, you would get a different thing, right? Actually, I want to demonstrate that. I'm going to cd into size of and mess with that. And it stacks size of.c. Okay, so I have another one I want to try here. So I'm going to say void decayed. I want to kind of create my own experiment. So I'm going to say char s message, okay? And I think that this is a thing. So let's do this. Print. So we have exactly the same thing here, right? In fact, we can even make it S if we want. And we can make size of S. So this size of decayed Google is written in Golang. Interesting. I mean, there's a lot of high performance stuff that's been written in Golang, so oops. Decayed. I want to call decayed here. Decayed S. Let's see. Expected. Oh, whoops. Yep, that's tool for the job. Sometimes it's the only tool for the job. Yeah, look at that. Oh my god. That's the decay right there. There's your decay. That is insane in the membrane. That is fucking insane. Size of array is 16, and it decays to 8, and then it's the same as 8. I have never been taught that. I have never been taught about pointer decay and I've never written any C that cared. But that is so important. I don't know. The only thing I can explain based on what the book says is that size of is that when you define a character array as a string, that internally C's compiler keeps track of how much memory's been allocated and how long that thing is. But as soon as you use it in any capacity that casts it implicitly as a pointer, which is what happens here, it's different. Now, what I want to see is not decayed. If you pass it as, well, we already know this, right? If we pass it as, we're going to get a copy of it. So this is different, right? This isn't decay. This is going to give you a copy. So if you do this, this is going to give you a copy of it. So then you can do this, right? You can do print. No, it doesn't make it slow. It doesn't make it slow. Garbage collection does not make Go slow. Compared to what? God, I wish people would stop saying that. I wish people would stop saying that. So printf after decay. So just array size of S, and this is going to be the same. This is a copy. A size of an array function parameter S will return size of character pointer. Yeah, I mean Java it's a problem, but it's not the biggest. I mean it's yeah. This is interesting. So size of, in this case, is not able to be calculated because we have the warnings going on. I kind of feel like we need to turn the warnings off on this. I can change C flags. I'm gonna turn off warnings on this because I wanna see what this does. I forgot how to do it though. So I think it's got to have the parentheses around it. I don't remember makefile syntax. C flags. Oh, it'll work if we get rid of the warning. Pretty sure. C flags equals. Come on, where are you, C flags? Oh, do we have to put a quarter on it? I don't remember. C flags equals. Error, no such file build directory. Oh, wait. What is it doing that for? Just all? You think I should just use all? Huh. No, because I think that's still turning on the warnings, right? I think that will still compile it, though. Yeah, it does. It gives you the warning. It still compiles, though. Size of the rate. Just the array. Oh, look, it's only 8. So that's cool because that means it actually decayed it even though I did it in the other format. That is fucking amazing. Oh, God. I feel like I understand that better than I ever have before. So I tried to do... I was hoping this wasn't going to be not decayed. This is decayed to 2. And it passes a copy because it's not passed by ref, right? So this one, every time you pass an array, it decays, like every time. So here we have, so that decays it because it converts it into a pointer. And because here's why. I can pass the S and it says, oh, you want to take it as a pointer? And I think, well, what happens if we actually pass it as the whole array? So I did this one, and then this one prints the same thing. They both print the same thing. So, you see what I'm saying? Both of them decay. Both of them are not passed by ref. No, C only passes by value. The value in this case is a pointer, and that's what C is doing. That's confusing the shit out of us. So when you hand I think I got my handle on this. I could be wrong. Somebody correct me if I'm wrong. But when you pass an identifier that's been associated with a character array, it automatically passes what this is. And what is that? Well, S is a pointer. It is a pointer. So it passes a pointer by default. The pointer is the value. It's not, so you can say, strictly speaking, it is passing by value. Yeah. So this is actually doing it. So in both cases, this is the one that really caught me off guard, because now you could do, what we need to do is we need to do decayed 3. We need to do something like this. We need to do this. I have to get a true test of this. Because this should be fine. I'm thinking, he famously said. So let's try that one. Wow, so that's 8 also. That's freaking me out. That's freaking me out. That is freaking me out. Look at this for a second. Look at this. So we passed an actual string array. It went in, but when this didn't keep it. This converted it into a pointer so that S is a pointer over here, and it still gives you an 8. The moral of the story: if you're ever passing a string, look, you should just never ever use size of. Not on anything string related. You should never use size of on anything string related, and I never have, and that's why I don't know it very well, because it's so fucking dangerous. It's not dangerous. It's just it's not intuitive. We'll put it that way. Because the size of the array before the k is 16, not because it's double the size, it's because that's how many characters are in it. I mean, let's make this thing a little bit bigger. Something long here. "16 characters." I know, but it's throwing me off. I want to. It's not, So yeah. So the only time that size of knows about the fact that it's an array is if it has never been transferred to another function. That makes it seem a lot to me like things are getting converted into pass by ref. It feels like it's getting passed by ref, but the reference conversion is happening before it ever gets passed. But it feels like it's forcing it to be passed by ref. And that's fucking annoying. I mean, that's like really annoying. Because the type of the string is probably SHA-21. Yeah. Yep. Because we didn't put a number on it. And so it identified it. It saved out that amount of memory and everything. But as soon as we did anything with it, we're doing some C coding. How's it going, Souza? Souza Leo, we're leading up to some game development in C. And right now we're just exploring something called pointer decay that happens whenever you pass a string of any kind through a function, which means you should never use size of. I mean, I'm just going to say it again. For when it comes to string stuff, you should never use size of against a pointer of any kind. Never. It's just too fucking problematic. I mean, we just proved it. So you should use string len or you should iterate over the thing. Size of is usually not going to do what you're expecting. Almost always. I think if you do size of against a malloc, I think size of has value later on when we start using malloc and structures and stuff like that. But when you're talking about character arrays, there's so much magic going on with character arrays that it's just a bad idea to use it on anything string related. Ever. Because if you move that code out, and you put it into a function, let's say you put it, look, let me tell you a real source of a major error here. So let's say you're like doing all this code and your function gets too long. Okay. Your function gets too long. You're like, oh, okay, I'm going to refactor. So you cut and paste this exact same code, stick it into a function, and pass it as a pointer like that using the thing. And your code fucking breaks. Why? Because the size of calculation is totally different, just like that, using exactly the same code. The only thing you did is take that code and put it into a function. That's it. And to anyone who's coded Python or JavaScript or Go or any other languages where they expect to be able to move code around and not have it behave differently depending on where it is in the code and whether it's in a function or not, those people are going to be very fucking surprised when they literally cut and paste this line of code and stick it in a function, and all of a sudden the value is completely different. Let's hope there's no like life support or financial transactions related to your refactoring because you just fucked the pooch. Poor pooch. I mean, I'm really glad we spent time looking at that. That is really huge. Because that is not an unusual circumstance to talk about. It is not unusual to expect a beginning programmer to come in. I know, I forgot it too. So I had no idea about this. I've been coding. I mean, I coded to IBM. I never used SizeUp, thank God. But it is not an unreasonable expectation to think, hey, if I take these 10 lines of code out and put them in a function, it'll just be the same thing. As long as I pass the proper type. But that is not true for C. Because if you pass an array, it will convert it into a pointer, and you'll get the SizeUp will no longer know that it's an array, and it'll give you the different values. So any of your SizeUp calls are fucked. If you don't take anything else away from this rant, take this away. Don't use SizeUp. With a character 21 as a type and see if it still works and copies the value. Yeah. I mean, if you're going to use SizeUp, just know what the fuck you're doing, and you probably don't want to work with. Do you want to do a for and actually specify it as an array so it doesn't take the thing? That's an interesting experiment. Let's try that. You're not passing the reference. We can't use the terminology of pass by reference because it doesn't apply here. The thing is being converted way before it's passed. C does not pass by reference. C passes everything by value. A second argument. Oh yeah, that's probably true. Yeah, we could try that. Let's try that. A pointer is a value. Yeah. Recover to create kid array. I have no idea. That's super interesting though, huh? So let's do a char. A chat. Let's do SS. No relation to the Nazis. 21. And let's see, after decay 3, size of SS. That actually worked. It just put our warnings up. Also, make sure you have your C flag warnings on there because they would keep you from doing this. If your warnings are on, it won't let you do it. Wow, look at that. Oh, I don't think it built. I don't think it even worked. Oh, wait, we need to call... I feel stupid. Okay. Wow. Same thing. Did I miss anything? Fuck. That is amazing. That's really amazing. Yeah, use stringline. But as Ancient Strains pointed out, don't use stringline if you're already going to iterate over the characters because that's what stringline does and you're just redundantly doing it. You don't need to. You can just, if you're going to iterate over the characters, use one of the functions that's there or check for the null byte or a boundary. Obviously, you don't want to just keep reading off the end of memory. But yeah, that's super interesting. I'm really glad we spent the time on that. We have a little bit of time left. Let's see what we can wrap up here. Pointer variables have types so they can adjust pointer arithmetic. And they're different based on that. So if you have, yeah, that's pretty damn confusing. I mean, pointers, I barely got my head around pointers and dereferencing before. Now that I know that there's like implicit rules that are happening depend on it. Pretty hard to nail that shit down. Do I really need to understand pointer arithmetic? Some coders avoid using pointer arithmetic because it's easy to get wrong, but it can be used to process arrays of data very efficiently. Can I subtract numbers from pointers? Yes, but be careful to go back before the start of the allocated space in the array. And that's the other thing. If you're doing pointer arithmetic, you talk about accessing illegal memory, start fucking around with pointer arithmetic. I guarantee you'll do it. Because you'll end up being off by 1 or something, and you'll point to like 1 byte. And you'd be surprised what people can put in 1 byte, man. 1 byte. Like in one byte of memory, they can put something in there. I mean, and then you'll be like writing to illegal memory and stuff. Can I subtract numbers from pointers? Yes, but be careful that you don't go back before the start of the allocated space in the array. When does C adjust the pointer arithmetic calculations? It happens when the compiler is generating the executable. It looks at the type of the variable and then multiplies the pluses and minuses by the size of the underlying variable. Go on. If the compiler sees that you are working with an int array and you're adding 2, the compiler will multiply that for the length of int and then get 8. Interesting. I do like this book. I really like it because it's pointing out some of the stuff that I did not know about. Does C use the size of operator when it is adjusting pointer arithmetic? Effectively, yes. The size of operator is also resolve the compile time. Then both size of and the pointer arithmetic operations will use the same size of different data types. Can I multiply pointers? No. Data structures in C. Yeah, we'll get there. Actually, there's another book, kind of a plug, in sometime in the year 2020, 2021. I really want, I don't know if we can fit it in, but I personally, I may do this on my weekends after I get certified for Kubernetes. C developer position. Long. I have a book from O'Reilly called Data Structured Algorithms in C, and I really want to work through the whole book, just for fun, because I really like that stuff. But I don't have any practical need for it at work right now. C does give you all kinds of understanding on multiple levels besides that, though, so I don't feel like it's wasted time. But that entire book is focused on data structure. I personally feel strongly that if you're going to learn data structures and algorithms, the way to learn them is in C, because they don't exist in C by default. You barely have strings in C. And if you call it a string, people look at you funny because it's actually a character array. Somebody will correct you. Some pedantic asshole will say, there's no strings. There's just, unless you're using include strings.h, there's no such thing. You're using a character array. Let me correct you there. I absolutely love that about C. I love that all the shit like binary sorts, you don't even have hash maps. So if you want to know why binary sorting and all that shit matters, learn data structures in C. Because in Python, you're like, oh, I have dictionaries and it's already made for me. And you have like really kick-ass hash maps, right? But in C, you have to write that shit. You have to write the algorithm that does the lookup of the item in memory, the hash map in memory, and there's different ways to optimize that lookup and all that O to the nth stuff. That's all based on C. And so there's no better language to learn data structures and algorithms in C itself, in my opinion, because it helps you understand why you need to understand that stuff. It does cover binary trees. This ought to be interesting then. Yeah, because, I mean, again, you don't need to know people learn JavaScript or Python as their first language. They're like, why do I need to learn binary trees? They're like, you absolutely don't. If you're going to be doing it in these languages, you don't ever need that. And so I feel like it's misplaced. Then again, if you're going to go do explain data structures and algorithms, you're going to do a whiteboard interview, you're going to be looking at your watch at you. C might not be the language used because it's going to be so slow to do it, which is why those fucking whiteboard interviews are so fucking stupid. What they should do is give you a week and say, hey, write us a binary tree in C. Not a binary, but implement your own hash map algorithm in C and return that to us. Okay, fine. Why did you choose this algorithm? Write 2 different hash map algorithms depending on what type of data is being stored. Increase your knowledge of C. Absolutely. I think it will too. Using pointers for data entry. You already know how to get user data from the string. So here comes the argv stuff. This is what they've been working up to. They've been working up to this because when they do ** args, you know, you kind of get what's getting passed at this point. You already know how to get to the user to enter a string from the keyboard with scanf, right? You can do it with scanf function. How does scanf work? It accepts a character pointer name. This part right here, actually. And in this case, it passes an array variable. By now, you may have an idea why it takes a pointer. It's because the scanf function is going to update the content of the array. Functions that need to update a variable. This is also why you have to have a 40 here, I'm pretty sure. Because if you don't have that, it won't have it. You can't use the notation where actually you couldn't use that anyway because that was in it. They can only use that in an assignment. The only time you can get rid of the number here is if you're using an assignment along with the declaration. And that implies the number from the size of the string that's right over here, the character array. Yeah. So it's because the scanf function is going to update the content of the array. Functions that need to update a variable don't want the value of the variable itself. They want its address. This is passed by ref. Entering numbers with scanf. So how do you enter data into a numeric field? You do it by passing a pointer to the number variable. What? Oh, and then it says, scanf says, oh, I have an int, so I will read one int in. I don't know. Yes and no, I guess. Because you pass the address of a number variable into a function, scanf can update the content of the variable. And to help you out, you can pass a format string that contains the same kind of format codes that you pass to printf. You can even use scanf to enter more than one piece of information at a time. God, this brings back so many memories. I totally forgot about this. It's like a flood of memories coming back. Enter the integer. Read one integer, then read a 29-byte string, character string, including the whole character, and then read a floating point number. This is cool because this kind of scanf shit, if you have a binary protocol, you can create binary protocols, and then as long as you know the organization of the data, you can inflate the binary data into variables and types and stuff. That's really fucking cool. This is really good stuff. Character's 20, last name's 20. Enter the first name, last name. This reads this reads a first name in a space. Then a second name. It's interesting though because it's like it has to be up to 20 characters. That's interesting. If the name has spaces in it, makes you wonder what it's going to do. Later in the chapter, oh boy. Printf. Printf. First name, last name, first name, last name. Enter first name, last name. Be careful with scanf. Yeah, I was going to say. I think we should probably stay with this scanf example. We're kind of done. Let's do scanf tomorrow. And we're kind of changing gears here. We were all about size up today. Let's do scanf tomorrow. Or whatever we're going to do. Actually, tomorrow is fun day, but we can still do C possibly. This info. Yeah, I want to code this example. Let's do it tomorrow though. So this looks really good. Thank you for hanging out on the C development. I am fading pretty fast, mostly because of the brandy and all the dinner I just had. And this is really fun though. I've been really excited going through this. Appreciate you being here. There's a ton of people to go watch right now. I can't say who's on right now, but please make your way over to. If you want C++, go hit up Strager. Strager's my favorite C++ coder. Besides CPP or whatever YPP his name is, PPY, PYY, something. But he doesn't talk. He just codes. And so I can't promise tomorrow I'm going to be here back at 8 doing C coding, but I have fun on the calendar for Friday night. So we'll see what that means. Preferably like collaborative fun of some kind. So we'll figure out what that is. I may or may not play Dota later tonight. I have no method of promising that. I need to lay down and relax for a second. What time is it? I may play Dota in like 20, 30 minutes. I can't promise anything. I have no idea. I just need to get away from the computer. I've been here since 11 a.m. pretty much, except for dinner. So I need to stand back away from the computer and do something else. But it's been fantastic. I don't regret it for a second. It's been a really fun day. So I may or may not be back for Dota. If I am, I'm just going to do it while I'm playing Fishies. I'll just change the title. So I'm gonna cancel the stream right now temporarily. I'll be right back with Fishies and music if you want that, until I decide what I'm going to do. Because I want the VOD to be done so that they can come back and watch the C and see the VOD, and eventually those VODs, all the C VODs are going to go up on YouTube.